Hello everyone, welcome back to Natural Language Processing course, and today we will learn on lesson 3. It is about text pre-processing. And here are the outline for these lessons. We will take a look on introductions to text pre-processing, and next we will learn the 4 steps in text pre-processing. We have sentence tokenization, word tokenizations, following by word stemming, and last but not least, we will learn stop word removal. Okay, come to the introduction part. As we have learned from our first lectures, when we talk about NLPs, we will learn on the task which we give computer to read and understand text, whether it is text article, text paragraphs. We give it as an input and we try to analyze what is this text about. And with the help of NLTK tools, it gives us modules which come with pack of full of library that allow us to help train the machines using some machine learning algorithms that are already implemented from the tool, so that we can try to understand the information from text. However, in order that we can perform these tasks, we still need to do a process called text pre-processing, so that we can work on the text more accurately. Okay, now we will take a look on the 4 main steps that are used in text pre-processing. The first one is sentence tokenizations. As we can see on these diagrams, we take an input from a file, whether it is a text, paragraph, or articles. And then the first step that we will do in text pre-processing is sentence tokenization. It will use to tokenize the sentences into separate sentences. For example, we have 5 sentences. So now we can have one by one in an array, for example. And next, in the second step, we have word tokenization. So for each token sentence that we already did in the sentence tokenization, we take each of the sentence to be processed in the word tokenization, which allow us to obtain list of words for each sentence. And next, we will do word stemming. So word stemming here is used to find the base form of the words. For example, the verb can be past tense, plural forms, or something else. We try to obtain those words in the base form. And last but not least, we have stop word removal. In this process, it is used to remove some unimportant words. We call it stop word in the sentence. So as the result from text pre-processing, we obtain an output which is a list of features, or we call it terms or words that are filtered from the given input text. So now we will take a look on the first process, sentence tokenizations. They are used to tokenize and segmented the paragraph into sentences. So from this process, we will get the outputs which are list of sentences. So we also take each sentence to be the input in the word tokenization process. For example, we have a text here. It consists of many sentences, right? So from the sentence tokenizations, we obtain for sentences. For example, the first sentence here, we have second, the third, and the fourth sentence. These are the output from sentence tokenization. And next, in word tokenization, we take one sentence by one sentence at a time from the sentence tokenization. And we use word tokenization to obtain list of words that are appearing in this sentence, so that we can get the terms, the keywords that are written in this sentence. For example, we have the input is a string. This is an example. So in the word tokenizations, we obtain each words that appear in this sentence. So these are stored in separate variables, for example. And the second example here, for example, the sentence say, a swimmer likes swimming, thus he swims. So from word tokenizations, we obtain each words in this sentence. Next, we come to stop word removals. So what are stop words? Stop words are unimportant words or unnecessary words that are used in the sentence. For example, we have articles, pronouns, and some other things. So considering the meaning of the sentence in terms of informative data, we need to filter those information. And from NLTK, it provides a list of stop words we can also find from this link. And from stop words, we have, after we know what are stop words, we can try to remove those stop words from the sentence which are in the stop word removal. So now we will take a look on these examples given a sentence here. I study at a school which is located near a supermarket. So from this sentence, we obtain here it is word tokenizations. So from these word tokenizations, we know what are subwords, right? For example, I here at which is an A here. They are subwords. So from here, when we do stop word removal, we try to remove all of these terms from the sentence. So after the result, we obtain these words, or we call it features. And this slide shows you about the stop words that are provided from NLTK. You can find more information on this, and there are some more than this that are not showing in here. So just to summarize, the stop words are those words that are not really necessary providing us information in a sentence. So next we come to word stemming. So what is word stemming? It is a process of finding base form of a word. So what it does is it will cut off the endings. For example, we have some words here. We have weighted, weights, and weighting. So from these, what the word stemming does is to cut off the ending. So from here, these are the variation, right? These are the ending to this word. So as the result, when we do word stemming, we obtain these words. However, we have some problems when we try to do word stemmings with irregular verb and nouns. Here, for example, we have studies. When we use third person singular with the verb that are ended with y, and it's proceeding with consonant. So in here we try to add IS, we remove y and add IS, right? So as the result from word stemming, what it does is to remove ES. So ES here is just the suffix that are added to the words. So from word stemming, what it does is to remove this. So as the result, we obtain the word study. So it is not correct, right? And another example is the word better. It is an irregular adjective, right? So we have the word better. So it's supposed to be the word good after we try to find the base form. But from word stemming process, we obtain the same words. It does not remove any ending. So it's not correct. So to solve these problems, we use lemmatizations. We call it lemmatization. So lemmatization is a way, it just works like word stemmings, but it works best more accurately with irregular words. For example, we given a list of words here, and when we do lemmatizations, we obtain those words in the base form correctly. For example, we have study, now we get the word study, okay, it's correct, right? And we have the word better, and now we obtain the word good. So we will see how we implement all of these 4 steps in text preprocessing. We have sentence tokenization, word tokenization, word stemming, and stop word removal. We will see in the implementation part how we can do it with NLTKs using Python programming language. So here are the packages that can be used to do word stemming. We have many available package that can be used, right? All of these are, we call it nltk.stem, and then it use some specific different API. For example, we have API at Steam, i3, Porter, and WordNet. So we will see on how we can use Porter and WordNet in our example. And given an example here, I went to study English with my friends yesterday. So after we do word tokenization and subword removal, we obtain some information, some words, right? So the word I, to, with, my in a sentence, they are stop words, so they are removed. So now we can only see only these 5 words. So from these, when we try to do word stemming, so from stemming, as we can see here, this is the result from word stemming. This is the result from lemmatizations. So this is not correct from word stemming, while this one is give more correct result. All right, so I think it's just a quick revise on what we have learned so far, and you may try to write down on your paper letters. It just summarize what you have learned in the what are the 4 steps in the text processing. Okay, so now we come to the second part, which is implementations, how we can conduct text preprocessing using NLTK. So in this example, it shows you sentence tokenization, word tokenization, and in addition to this, we have we call paraspeech touching. So in short, we call POS. So paraspeech gives us some meaningful information. For example, in the sentence, this word is playing role as verb, noun, object, or something else. So in LTK, we need to import this library in LTK, and we have this sentence as an input. So to do sentence tokenization, we can use this function. So you just simply say nltk.send tokenize, and you pass a parameter which is sentence. So next, from sentence tokenization, we get list of sentences, right? So now we use loops to try to find each sentence, and then from each sentence we pass it to the word tokenization process and post touching. So as the result from this code, it gives you just general information on how your sentence look like. For example, the first sentence in this input sentences, we have this is send 1, right? So the first here, it is obtained from the command print tokens above, and the second one, it is obtained from print text command. So this shows you about this. It is a dt here means determiner. This is a determiner. It is a verb, and sentences here it is some additional paraspeech form. So this just gives you a general information on how a sentence looks like when we try to use NLTK. So next, we will see on how we can do word stemming. So in word stemming, we need to import some libraries. For example, in this case, we use Porter stemmers. We can include this library using this command from nltk.stem. We import this one. So there is also another syntax that we can use to import a particular packages. For example, in here, we know that Porter stemmer is appear in nltk.stem, right? So you just use only this. It works the same in this one. They are equivalent. And so now take a look on the inputs. So we have word here and we have words 2, and we will use word 2 in this one. So we not, this is just another example. Just we give the input sentence, the input words. So in the variable words 2 here, we have the word wait, waiting, waited, and waits. So to be able to perform word stemmings, we need to create an object which belong to a Porter stemmer using this code. And next, for each words in the sentence, in the given inputs, so we try to do word stemming using this function stem. So by calling to the method in the object PS, and when we pass a parameter which is a word, and then we obtain the stemming word from this. So it seems this is giving you a correct answer, right? Okay, next we'll see on some other terms that are not work correctly with word stemmings. As we already discussed before, word stemmings, it is used to find base form by only cutting off the ending from the word. So sometimes it's not really give you the correct result. For example, in here we have the words studied and studies. So as the output from these, we obtain these, right? Study. It is not correct. So what we do in this part, we come to lemmatization. So from lemmatization, okay, we do the similar way to word stemmings, but we use another package called WordNet Lemmatizer, and we create an object. And next we can we call it lemmatize function, object name dot function name, and then you pass a parameter. So from here, as you can see, even it is an irregular words, better. It also has a problem in here, but better, and you obtain the word better, as you have seen. As you have seen in this output, better, it gives better, because in lemmatization it provides you two syntax. The first one, as you can see in the first three, from line 5 to line 7, you does not need to provide a para speech of the word, but in this case you will not obtain the more accurate result. For example, the word better, it just gives you the same word better, right? And the last command in line number 8 in this example, we try to pass a second parameter into the lemmatize function, which is para speech, POS. So here you say POS equal to A. So A here means adjective. You may use we equal to verbs or some others para speech short term. So from here you give a correct result, better. You give the base form is good, right? Okay. And next we see on the second example using lemmatization. We have this term gaming, games, better, studies, and studies. So this is the output on the bottom left here. This is the output from this program. As we have discussed earlier in the previous slide, when we does not provide para speech parameter in the lemmatize function, we does not give always the correct result. For example, the word better and studied here, it is not correct. So in here we should also study on how we can use post touching, para speech touching, so that we can use this verb, it is belong to a particular para speech. And next we will see on stop word removals. And from NLTK, as we have seen in the previous slides, NLTK provides a list of stop words, right? So in order that we can display these stop words, we can use this codes. From the left here, we include stop word from nltk.corpus. We import stop words. So we just simply using a print command, and then stop words, and then you pass a parameter which is a language. So in here you pass English, so it will display you the output as showing in this slide. So these are stop words providing from NLTK. For English, for some other languages, they may also have these stop words. So concerning these syntax, you can just provide the parameter, which is the language name, English, French, or some other things. And another way of writing, of displaying the stop words, we can just only import NLTK, and next we try to access to the stop word here using the syntax nltk.corpus.stopwords and dot again. So what are different between the first example code here and here? Thing here is like you import something and then from something you import the stop word. So now you can use stop word here. So in here you don't use from, you use only import. That means you can use NLTK in the below codes. So you need to access to each of the sub packages providing by NLTK, which is corpus, stop words, then words. So it works, give you the same result. So next we will see an example of how we can do the whole text preprocessing. Mainly we focus on stop word removal, and we have here we need to import stop words, we need to import word tokenize, or rather than this we can just use import NLTK and next NLTK.word tokenize. It's all work the same way. So from here you have a variable called filter sentence. So in this red rectangle highlight here, it is the first way that you can remove the stop word from the sentence, or you take only non-stop words from the word tokens. So from word token you have list of word. So this syntax, it means you try to loop for each word in the word tokens and you take only the word that are not stop words. So you see this is a short term in Python. It's really short, right? Only one sentence, only one command you can obtain those filter sentences, the words, and the stop word are already removed. And in the second method that we can use is just a normal way. We use for loop in the blue rectangle highlight here. We use for loop, and then you try to check a condition. If something is not what you want, so you are checking with stop word. If it is not in stop word, you will append it to your array. So using the append function. So these sample code give you the same results. So as you can see in this output, the first line we get those terms that are appearing in the sentences. We obtain this one. We already removed the stop word. So we have went, study, English, friends, and yesterday. So among these, the word stemming is not yet applied. So this just gives you an example of how we can do stop word removal. You may need to do word stemming in order that you can find the base form of the word. Alright, so I think we have learned many things, and I hope that you will do some homeworks so that you can practice on how you can perform text preprocessing from the text. So in the first homework here, you are asked to write a program to get one sentence from a user, and then you try to do some steps from text processing. The first one, you do word tokenization and display the output from this process to the screen as well. So this is just a command line. You display it in CMD. And in the second, in B, you do word stop word removal and do the same thing, and then you display it. And we have words stemming lemmatization, which we already previously discussed. And we notice that when you run the program, make sure that the program is not stopped until the user input the word exits. So the input from here is one sentence at a time, right? So be sure that you will stop the program only if the user input the word exit. And we have another second homework, which you will try to work with text file. Suppose that you create a file called data.txt, and then you add some sentences. In total, there's 7 sentences. You can edit by your own or copy it from somewhere. And then you try to perform some text reprocessing as the following instruction. In the first instruction, A, you do sentence tokenization. B, words tokenization. C, we do lemmatization. And D, do stop word removal. But we notice that for each of these operation, you need to store the output of them into a corresponding file. For example, when you are doing exercise A, you need to store the output in the file called sentence token.text.tat. If you do word tokenization, you need to store those output in the word token text. Alright, thank you for joining our lecture today, and we hope to see you in upcoming lectures. And here is the reference from this one. Okay, see you in the next lecture, everyone.